Yeah, hi everyone. So let's start talking about number system. Okay, so in the first session, you have seen my roadmap for 82023 for electronics and communication, instrumentation, electrical engineering, and computer science. So in this session, I'm going to talk about number system. Okay, and in fact, once the number system will be completed, we'll go to next topics, right? So please share this session. Okay, this session is going to be very useful for for first year, second year, third year, fourth year, and droppers. Okay, wants to go for digital circuits, right? Who are interested in digital circuits. In fact, they want to score complete marks from the subject, right? So let's directly jump into the whiteboard. That is our favorite board, right? So let's start this. So we'll talk about number system here. You might be also familiar with number system because I think you talk about numbers from your first class only. Okay, so in class 6, class 7, class 8, many things you study, right? Number systems are basically what the method of representing numbers. Method of representing numbers, you can say. Method of representing numbers in a system. We'll see different kind of methods. So, what are the properties? What are the features we are going to see for the number system? Few keywords you will always find in case of number system is number one is gonna be your base. You can say base or radix. We'll call it radix of that number system, right? So you have to understand what is base, what is radix. Okay, both are same here, right? So it is the number of digits in a given system. So any system will be given, right? So if you'll see that, right? So what is the base? What is the definition of base? It is the number of digits in a given system. Number of digits. Uh, and so any system will be given. We will give you the example. So suppose we are taking one example here. So example number one. So we have to understand this definition, right? So if someone is going to ask you what is base of particular number system, so you have to see the number of digits in that case. If I say there is a base, right? This is the base and we represent base as R, you can say, because base has also the name that is radix R. And here we will write symbols and here we will write, so suppose we have got base 6. We have got base 6, right? So how many numbers will be there? How many digits will be there? You can see here. So it has 0, 1, and 4 and 5. So here you can see it starts with 0 and it ends with 5. So you can count the number of digit here. So 1, 2, 4, 5, 6. Okay, there are 6 symbols, right? And if I talk about base 12, right? In case of base 12, what will happen here is that you will start with 1, 3, and so on, right? Okay. Uh, then 9, then after 9 you have to use some alphabet, you have to use some letters, right? So A, B, okay, so A stands for 10, right, in our case, and B stands for 11, right? So you have to go for you have to count the number of digits or number of symbols in base 12, right? So there are 12 symbols, 0, 1, 2, 3 up to 9, then A and B. And if I talk about 32, the base is 32 here, so it will be very, I mean, 32 symbols you have to say, 1, 2, and so on, right? Then 9, A, and so on, right? Then U. And also you can have the base system, right? So base is basically what the number of digits, the number system. This simple definition you can keep in mind always, right? In our case, what are the numbers, I mean, what are the base we are going to see? We are interested. So we will see base 2, base and symbol here you can write. So we will talk about base 2. In base 2, what are the symbols are there? There are 1, 0 and 1 only, right? There is a base 2, okay, that is represented by R, right? 0 and 1, and number of digits are only 2, 0 and 1 in case of base 2. Base or radix, base or radix, what has 2 digits only, right? Next, wha- next will be octal or 8. Case of 8, 0, 1, 4, 5, 6, and 7. So suppose you are writing something in octal, right? So it has base 8, right? So whatever digit will be present inside this bracket, okay, that digit should be less than the base. Suppose here I am writing 1, 2. This is correct in octal system. So all digits should be less than the base. All digits should be less than the base. Okay, this you have to maintain. This you have to maintain. If I'm going to write like this, suppose I'm writing any number, right? That is 1, 9, and I'm writing 8 here. So this is wrong. Okay, why it is wrong? Because the digit here 9 is not allowed in base 8. Okay, in base 8, digit 9 is not allowed. Whenever any question is given, this is wrong. And it has also got some base years. You have to check always, right? You have to examine, right, whether it is a correct number system or not according to this base, right? So see, 127, right? Base 8 is correct because 127 is allowed in base 8 number system. Understand? So this you have to keep in mind. So base 2, okay, it is known as binary. Binary, okay. What my computer understand, okay, and this is octal, right? Base 8, and we'll talk about 16, right? 16 will be hexadecimal, right? Hexadecimal. So here 0, 1, 2, 3 up to 9, and then A, B, C, D, F. These are the symbols, okay? These, and you can also associate 10 as a base, right? So 10 is the base, okay, you can say, and it has name decimal. The decimal number system, and decimal number system has got base 10. What you study always in your school days, or okay, computer only understand what? Computer only understand binary. Whatever whatever representation you talk about, but after all your computer will understand binary, okay? Your computer will understand only machine code, 0101 kind of, okay? So decimal number system, in decimal number system, the base is 10. And what is the symbol or digits allowed here? That is 0, 1, 3 up to 9, right? It should be less than 10. Okay, remember. So if any number system is given, okay, having base, any base, right? Suppose we have written here, 1, 2, and 9, as I gave you the example, and it is written 8. So it is a crime, okay? Don't write like this. This is wrong. The correct is what? 1, 2, 7, you can say. Correct. So all the digits which is present inside this, okay, having base 8, should be less than the base. This is one important point you have to keep in mind. Always. Okay, most of the aspirant ignore these things. So I hope this is clear. You can also have base 5, okay. You can also have base 5, right? So base 12 means 0, 1, no, up to B, A and B, and base 5, okay, base 5 can also be over there, right? So base 5, base 4, whatever base you want to talk, you can talk, right? So number systems are called as positional weighted system. So let me go to next slide and talk. So guys, I will also share the PDF if you want, right? You can comment in the comment box if you want PDF of this no lecture, right? So I will share that. So you can share this lecture among everyone. So let's talk about next point. That is second point you can say, that is number systems are called positional weighted system. You have to understand from the name itself. Positional weighted system. Positional weighted system. This is very, very important. If the base is R, suppose, okay, let me generalize. If the base is R, the base is R, small r, you can say. Then how can you write the number system here? Okay, position based on positions, positional weighted system, you can say, right? So we can write like this: r to the power 0, r to the power 1, r to the power 2, r to the power 3. Okay, there will be one radix point. You can say this is a decimal point here, that is also known as radix point. So radix point. To the left, you have to write what? R raised to power 0. So you have to put positive powers here. Okay, exponent should be positive here. R to the power 0, R to the power 1, R to the power 2, and so on and so forth, right? And R to the power, you can say, um, n minus 2, R to the power n minus 1, you can say like this. And right to the decimal, or you can say radix point, here it will be r to the power minus 1, r to the power minus 2, r to the power minus, and so on. So this is what the number system, and which is what? Positional weighted number system, right? So you have here r is basically the base of that number system, right? So let's talk about some of the examples so that you could understand. So I'm going to write here the number system which we are focused on, I mean, which we will be talking and this entire course of this circuits. So here you can make the table, okay, that is system here, and then we will talk about the base, or you can say radix, and then the symbols, and what are used in computer. You have to say yes or no. Okay, so this is one of the very important key you must know, right? So first, very familiar, which we know that system is decimal number system, and the base is 10 for this. Okay, and what are the symbols allowed in this case? That is 0, 1, 2, and so on, 9. Okay, and can you use decimal? Can your computer understand decimal number system? Please answer in the comment box. Can we use decimal system in case of computer? No, right? Here you have to answer no. Next is your binary. Okay, binary number system. Binary. It has got the base 2. And what are the symbols allowed in this case? What are the digits allowed in this case? Only 0 and 1. Okay, I told that if you will write like this, you will write 0, 2, and here if you will write 2 or 3, so that is wrong, right? So whatever digits are present, right, in that number system should be less than the base of that number system, right? That is very, very important here. And if I ask, can computer understand binary? Yes. So here you have to write big S, right? Very important. And the third one is hexadecimal. Hexa. So it has got the base 16, and the symbols are like 0, 1, and up to 9, then A up to F. And can your computer understand hexadecimal? No. One of the very important fact you have to understand. And the fourth one is octal. So octal means the base is 8, right? And what are the symbols allowed? That is 0, 1 up to 7. You can see what are the digits allowed, okay, should be less than the base. That this conclusion you have to write in your short note. Okay, so this is what the number system is, which we will be studying. Okay. In fact, we will be using for the course, further lectures. I mean to say, right? So, okay, so let's talk about some of the conversions. We what we will see here. Okay, so number system conversion basically we will see. Okay, so I hope you understood what are the base. Okay, what are the number system we are going to see and we are going to study, right? And yeah. So number system conversion. So we will see the number system. Okay, already we have seen number system like decimal, binary, hexadecimal, octal, right? Number system conversion, which you know already. Okay, so we have got the very first kind of number system, that is decimal. We want to go from decimal to any other, right? You can say any other. So we can go from here to here. Can convert decimal number system to any other, okay, or vice versa also you can do from any other number system to decimal number system. So this is one of the uh, you know journey we have to make, right? We have to go from decimal to, or you can say decimal to any base, any base, or any base to decimal. And we have to see this is first, and second one we have to see is from a hexadecimal to octal. Hexadecimal octal. So you can't directly convert from hexadecimal to octal. Remember, you have to go to some intermediate step as well, right? If you want to convert from hexadecimal to octal, right? Suppose you have got hexadecimal here, and you have to go to octal, right? You can't directly jump from here to here. Right? You will have to go first. You have to convert the hexadecimal to binary. Then you can go like this. So this is the right you can say graph, okay, which shows that how we are going to convert hexadecimal to octal. And the same is applicable for octal to hexadecimal as well, right? So you can go from octal to the slow graph here, that is binary. Then you can come back here, but don't jump directly from hexa to octal. This is wrong. You have to follow, go to some intermediate step. So these are the things which we will be talking. Very quickly we will revise because these are not tough topics, right? And we have to mainly solve the problems has been asked in gate or supposed to be asked in gate. Okay, so let me talk. The very first is the decimal to other systems, any other, right? So let me take decimal number system, decimal to any other system, right? Decimal to any other system. So you can have two kind of numbers. One can be the integer, and one, I mean, you can have two parts, integer as well as fraction, right? So for integers you have to keep in mind these things. For integers, right, integers, what you have to do, and for fractional part, what you have to do. For fraction, or you can say fractional part, or you can say write fraction here, what you have to do. So these steps you have to keep in mind. So for integers, what you have to do, you have to you have to make successive division, okay, by required base. So you have to make perform successive division by required base. Required base means in what number system you want to convert, okay, decimal to any base, right? So successive division you have to perform by required base, and then collect all the reminders from bottom to top, and collect all reminders from bottom to top, because already you have studied when you divide something you will be having remainder and all those things, right? And in case of fraction, what you have to do, you have to multiply fraction by required base. You don't have to divide here. You multiply fraction by required base, and then what you have to do, and collect all the integers, not the remainder, remember, okay, because you will not get remainder here because you are multiplying, you are performing multiplication, right? And collect all the integers from top to bottom, top to. So this is very simple. I think if you keep these important statement in your mind, you can do. Let's see some example here. Let's take one example. Suppose you have got number as 37, okay, which is written in base 10, and you have to convert into binary, you can say, or base 2. Okay, so what shall be the uh, okay, what will be the number? How you can represent 37 in binary? Okay. So the way as far as this number is concerned, it looks integer only. It does not have any fractional part. So we can perform what the uh, successive division by required base. So what is the required base here? That is 2. You divide 37 by by 2, so it is going to be 18 here, right? And then 2 will be 9. So you have to also collect the remainder. So what reminder you will get? Okay, you will get here 1, okay, because 36 will be here, so 37 minus 36 1, and then you can say 2. Here what reminder you will get here is that here you will get 0 as a reminder, and here 2 you can say 4, get 1 as a reminder, then get here 0 as a reminder, right? Then 1, right? So I hope this is clear. Okay, so again you will get no, you can say 0 here, right? And now everything is okay. So you have to end when you will get 1 here, right? So what you have to do, you have to collect all the remainder from bottom to top. So let me write here. It is in base 2, and you can start from 1 0 0 1 0. This is correct. Okay, now you have successfully converted decimal to binary. So in case of decimal to any number system, any base, you can say, what you have to perform for the integer part, right? If your number is having integer part only, right? So you have to divide. You have to perform successive division, right? So I hope this concept is clear for everyone. And next example, let's take one example here again. So you can also put some positional bait of this binary here, right? So see, if you want to directly find 100 101, right? This is what base 2, because all the digits are less than base. You can also write directly in decimal, right? If you have got binary here, put the positional weight of this number, right? So 1 is what? That is 2 raised to power 0. Here it is uh, raised to power 1, right? You have to multiply as well, and this is going to be 2 raised to power 2, right? So this is 2 raised to power 2, power 3, 2 raised to power 4, and 2 raised to power 5. So you can add all these weights, right? So 2 raised to power 5 means 32 plus this is going to be 4 1. So what you have got, that is 37. You can directly convert binary to decimal, okay, just by using the concept called positional weight system. Okay, with the help of positional weight system. See, you don't have to write anything here because they are 0, so they will not contribute. Okay, so I hope this is clear. How to convert decimal to binary or any number system, and how to convert binary to decimal or any number system to decimal. So you have to go use positional weighted system, right? Concept of positional weight. Next. So let's take again one problem here. Suppose you have got one number, example number 2 I'm taking, 7682. Okay, it is given in your decimal number system and you have to convert in 16, or you can say hexadecimal. So as far as this number is concerned, it is integer, so you can again divide. You have to perform what? You have to perform division here. It's successive division, you can say. So you have to divide by 16 because now the required base is required base 16. Just divide here, right? So 16. So here you will get 480. So whatever base you will get, that is 2 here. Okay. Then in further divide, you will get here 0. Then 16. Okay. So you only can go for one time. Okay. It is going to be what? Uh, 30 minus 16 is what? That is 14. 30 minus 16 you will get 14. So you can say that it is equal to E. Okay. And then there is a 1. No problem is there. You don't have to go for further, right? You can say 0. You will get here 1. So you can collect now from bottom to top. So you will get here that is 1, 2 and 2. Okay. 1 is 0 and 2. So now you have successfully converted from decimal to hexadecimal. So if you want to go from decimal to any number system, so you have to perform success. I hope this is clear. Successive division and collect all the remainders uh, from bottom to top. I hope this makes sense to everyone. Next. So what you will do with the fractional part, right? If you have got some fractional part, let me take one example here. Fractional part, suppose you have got 0.625, okay, and it is given in your favorite decimal number system, okay, what you study always. You don't study about binary, hexa, okay, in your real life. 0.625, you have to convert into, you can say, in binary, okay. What you have to do in integer part, it is 0 here, the fractional part, right? So if fractional part is given, so you have to multiply fractional part with the required base. Let's do successive multiplications. 0.5 into, you have to multiply this, so you will get here 1.50, right? So you have to collect the integer part from top to bottom, right? So forget about now. Just take this one here, and now again multiply fractional part, that is 0.250 into 2. Don't multiply again 1.50. Just take out this guy here, collect that immediately, and again multiply fractional part into by the required base. You will get 0.5. Here the integer part is 0. 0.5 into 2, 1.0. Now you have to stop in here. You can collect from here to here, that is 101. So your answer will be what? 101. Okay, so it is 0.01, right? For fractional part. So in case of fractional part, you have to do the successive multiplication. In case of integer part, you have to do. So because there will be radix point, left to the radix point, integer will be there. Right to the radix point, okay. So this is a radix point, okay. This part is going to be integer. Part is going, okay, your fractional part. So for integer part, you have to do successive division, right? And for fractional, you have to multiply and go from top to bottom. And what you have to collect here is you have to collect integers. Collect. So I think you know what is integer, what is real number, what is rational number, and all those, right? Those things you study in your class 8, class 6. Basic things you must know, right? So I hope this makes sense. Sometimes what will happen here is that you will keep multiplying fractional part with the required base, but you will not get 0 0 here, 0.0 kind of, and your number will I mean your integer will get repeated again and again, right? So you have to stop, okay, from where it gets repeated. You don't have to uh, continuous continuously make the multiplication, okay, right? So you can also take the example how to convert decimal to octal. So this is given as 539 decimal number system. You have to convert into octal. Again, you have to do what? You have to divide. You have to divide what? You have to divide number by squared base, that is 8. Right? Will be 67. Have to collect the remainder, that 3. Have to, that is 8 times 4. So you get here 3, I guess, again. And this is 8 1 is 0, and collect will be what? 1 0 3. Observe what are the key observation you can make here. Whatever digits are present in this number system having base 8, all the digits are less than base. All the digits are less than base. This is very important fact you have to keep. Okay. So I hope this is clear. Uh, but in case of hexadecimal to octal, octal to hexadecimal, that is very, very easy. I'm just going to explain. Don't worry. And I have also told you that, but I have told you that you can also go for any other, any other system, decimal number, any other system to decimal system. What is the technique? So you have to multiply the digits with the corresponding weight. I have told you that you have to go for, you have to use positional weight system over there, positions of the weights. Right? What you have to do, whatever digits are present, you have to multiply the corresponding weight with that digit and add them up, right? So any other system to decimal, decimal system, any system, whether it is binary or can be binary, can be hexa, can be octal. It can be any ways to decimal system. So what is the trick here? You have to remember this trick. Multiply the digits, multiply with corresponding weight, corresponding weight, okay, and sum all of them, and sum them up, all of them. Job is done. So if you keep in mind these one or two statement, you can do. So let's directly see the example because we are preparing for gate. If I have written some statement, so we need to justify that. Okay. So here again, you will be having two parts. One will be for integers, and for fraction. So after the radix point to the right, okay, you have to put base to the power negative power should be there, okay, negative exponent should be there, r to the power minus 1, r to the power minus 2, and in case of integer, r to the power 0, r to the power 1, okay, it goes like that. I have told you in the beginning as well. For integer and for fraction, both this statement is applicable, right? Statement is applicable for both, for both uh, for both, you can say, integer as well as fraction. And please keep this in next. So let's see one example here. So any number system to, I'm talking about decimal number system. Let me take one example. So the example number one is 27, and which is given in base 8. You can see all the digits. The very first check you have to make is all the digits are less than the base. Suppose you have to convert this guy in decimal, that is 10. Okay. What you will do here is you can convert like this. What is the digit here? 7. What is the digit here? 7. Okay. So you can say 7 into what is the corresponding weight of this digit, right? You have to write this r to the power 0. So that is 10 here. 10 to the power 0 plus corresponding digit is 2 here. And here you have to say 10 raised to power 1. Now you can add all these things. So this is 27. Okay. Okay. So I hope this makes sense. Yeah. So yeah, you have to keep in mind this here. I think we have made some mistake. Okay. Please make sure we have just converted the same, right? We are getting the 27 only because we are converting from decimal. Okay. See, this is 27 here. So what you have to do here is you have to take this 7 here, right? And multiply with this, okay, the base to the power, this base you have to use 8 raised to power 0 plus 2 into 8 to the power 1, right? Don't use this base, required base. What you have to do here is you can write here, this is very important point, multiply all the digits with corresponding weight. So I'm not talking about the ways you want to convert into, right? I'm talking about the number where the number the whatever base is given, right, the same base you have to multiply here. Okay, don't use this, otherwise you will get the same number, right? Okay, so that kind of mistake we can do as well. So 27 base 8 is given, and this is x here, right? So you have to convert in decimals. So now you have got this is in 7, right? 16 plus 7, I guess you can add this and get required result. So this will be 23 decimal. What you have done here is, this was the digit. You have multiplied with the corresponding weight, that is 8 to the power 0 is the corresponding weight, plus 2 into 8 to the power 1. Suppose any third digit would have been over there, so that third digit into 8 to the power 2, and so on and so forth, right? We will add this, you will get. Let me take one more example, an example where integer part and fractional part both are given. So ab dot 8, right? And it is given in 16. You can understand, you can't write 8 here, that is going to be the crime. Okay, ab dot, the radix point here, right, is given in hexadecimal, so you have to convert into decimal. What you can do here is, again, let me show you the same, right? 8 into 16 to the power. So but this is one, again, very big mistake we are doing. What big mistake we are doing is, you have to understand this. Okay. You can see here, there is a fractional part, right? So what you have to write here is that you have to take this digit and you have to write into the power minus 1. Okay, don't start with 0, okay, because it is right after the radix point. Okay, for fractional part you have to take base to the power negative powers. There should be base to the power negative, base to negative powers, base to negative exponent, you can say, right? I hope this makes sense. And this b is there, so b means 11, right? So b means 11 into power 0, and a is meant for 10, just 10 into the power 1, right? Now you can add all, just add. You can say that this is this, you can say, is 160 plus the 11 plus 8 upon point 5. You can add this and you will get here as 171 plus, you can further add this, you will get 171.510 decimal. So what mistake you can do here is, if there is a fractional part as well, right? So you start with the base to the power negative powers, right? Negative 1, negative 2, negative 3, like that. If you're going toward uh, right side, and if you're going toward left, so you have to take that digit, multiply with the corresponding base to the power 0, and all. It is, if it is in unit place, you can say tens, like that. So 16 to the r to the power 0, r to the power 1, r to the power, if the radix point here, so r to the power minus 1 or minus. Please keep in mind this general representation of any number, okay, any base. So let me take one more problem here. Right? Suppose your base is x. Suppose your base is x. Okay. So 3 to 5, and your base is x here, and you have to convert into decimal. So how can you write this? You can write this as 5x raised to power 0 plus, take digit, multiply with the corresponding weight, take digit, multiply with the corresponding weight. So here you are getting what? The quadratic equation kind of, okay. You have got here what? The x square plus 2x 5. Okay. So yes. So you can also determine what can be the base of this number system. what is the value of x, what what is the value of x here. Okay, so how can you determine the base of this, the base, what can be the base here. So you can see the maximum, you have to always check the maximum digit. Okay, so what is the maximum digit? As I told you that base can be, base must be what? Base must be greater than or equal to the maximum digit, maximum digits present. So if 3 to 5 and the base x is given, so you can directly tell what can be the x value. X cannot be what? No. Here you can see the maximum digit. Okay, you can see the maximum digit is what? 5. 5 is the maximum. Should be greater, right? Always greater. So okay, so remember whatever number of digits are there, you can see 2, 3, 5 is there, right? And the maximum digit is 5. So base is going to be what? Base can be equal to 6 or greater than, no. So you have to remember this. So it can be greater than or equal to 6 for this. Correct, okay? Because see, it cannot be 5. Okay? It cannot be 5. It cannot be, if your base is 5, then the number of the symbol allowed are only 0 to 4, right? This is how we can find the base directly. So these digits, whatever digits are present, should be less than the base. And this you have to keep in mind. This is one of the very important observation. Next is okay. So next is, let me finish this. Okay, by so next, in the next session we will take some examples, some problems, right? Suppose we have to convert hexadecimal octal, hexadecimal to octal. So what you have to do here is, let me take directly one example here. Suppose you have got 3b 3b 3, right, in base, and you have to convert octal, right? So you can't directly convert into octal, right? So what you have to do here is, you have to convert this 3be binary, then you can convert into octal, right? So this is one intermediate step you have to perform. So what you can do here is, you have to put corresponding binary number, right? Binary digits for E, for B, for 8. So okay, so you can see this is 16 here. It means that 2 raised to power 4 is, so how many bits should be there? Okay, so we will talk about bits. What is bit basically? Bit is basically your binary digit, nothing else. Digit. What we have done here is, we have taken this bi from here, or you can, and we have taken it from here, right? So you can say bit is what? The short form of binary digit and nothing else, right? Bit is basically 0 or 1. So we'll talk about bit. Okay, we'll talk about byte as well. Bit, byte. We'll talk about nibble. These are the important facts, right? Bit. In bit, there are 2 digits, 0 and 1. In case of nibble, there will be 4. This is 4 bit. In this case, byte means the collection of 8 bits. Byte, B byte T. 4 digits, 8 bits. So we need to keep in mind one table as well, right? Suppose 0 is there, right? So you have to convert into 4. You have to convert into binary, so it is going to be 0, 0, 0, right? So you can use 8, 4, 2, 1. 8, 4, 1 trick here, right? This is corresponding weight, okay? 2 raised to power 0, 2 raised to power 1, 2 raised to power something. Suppose 1 has to be written in your binary, so it will be 0001, and we are using 4 bits. 2 can be written as 2 can be written as what? 2 is here, right? So 0010, 3, for 3 you can say you have to add 2 and 1, right? So you can say 0011, 0011. For any number you have to put corresponding you can say this is a decimal number 3, and you have to convert into binary, right? Corresponding binary value, binary digits you have to put, right? So for E, and that too 4 bits you have to use. So directly you can write, so 3B E is there, right? You can convert what is the corresponding 4 bits for 3, that is 0011, and for B is 11, right? So B is 11, right? So you can say that is going to be 1011, and for E 1 for E, right? You can put, so it is going to be 110 in binary. So these tables we will discuss, don't worry. Okay, just for the moment I am telling you. So using weighted position weight, right? We can convert into binary. Binary conversion is very easy. And now what you have to do, as you are converting into base 8, right? So you have to pair 3 binary. Is 3 you have to pair. You can say this is 110. So 110 is what is the corresponding octal number for 110 means you can say this 6, going to be 7, going to be again 6. You can say this is corresponding 1676. Okay, base 8. So what we have done here is we started with hexa, and now we got octal. So this is one intermediate step you have to perform always. It is very easy. Once you will solve the question, uh, you can convert anything. Okay. Let me convert octal to hexa. Octal to hexa conversion, this is very important. So octal to hexa means let me take one example here, that is 378. Base is 8, and you have to convert into base system, right? So again you can't directly write hexa 1, right? So what you can do here is you can convert into binary first. 367 to binary, what you have to do here is you have to put corresponding 3 bits for 7, corresponding 3 bit for 6. Okay, binary 3 means 110, you can say, sorry, 011, not I have written here, so it will be 011, and for 6 you can say this is going to be 110, for 7 111, 3 bits only given in. Now in case of 16, in case of hexa, you have to pair of 4 bits. If there are no you don't have enough number of bits, you can add other 0. You can say this is going to be what will be 7. Okay, because 8 4 2 1 you have to always use 0 1 1. 4 2 plus 1, that is 7, and this is going to be f, and this is 0. You can say you have converted successfully to f. So intermediate step you have to keep in mind. If you want to convert from octal to hexa, what you have to do, you have to put 3 bits, okay, for the binary digits. I mean for binary conversion, uh, all the digits corresponding digits which are given in octal number system, you have to write 3 bits for them, corresponding to case of binary, and then make 4 digits altogether. I hope this is clear. So let's take some of the question, in next session, okay? Because I think theory is done. Theory is done, and we will take some of the. So your theory is done, right? And we will take a few questions which are most expected in the gate examination, already asked in computer science, medicine, electronics, and electrical. So I hope you might have enjoyed complete session. It was quite easy, right? And if you have any difficulty, you can comment on the comment box. I will again, explain all the topics. Thank you so much. We'll meet in the next session with the problem solving. Okay. Thank you.